Hello everyone, in this video let me solve some problems which are taken from GATE 2017 Engineering Mathematics questions related to the topic calculus, subtopic limit continuity and differentiability. The needed definitions and concepts for solving these problems are explained in the concept video. I give the concept video link in the description box. Keep watch if you need to. Now let's move on to the problem. The first problem is here let f from R to R, g from R to R be defined by f of x and g of x are defined here, where R denotes the set of real numbers. Then at x equal to 0 we have to check whether f and g are differentiable. F and g are differentiable. This question is from XE department. It has 2 marks. First I have to check the function f. So I took f dash of 0. F is differentiable or not at x equal to 0 only. So I took f dash of 0. This is the definition of derivative. Limit h tends to 0. F of 0 plus h minus f of 0 divided by h. Limit exists. F dash of 0 value exists. That means limit exists. Then only it is derivative. F is differentiable. F is differentiable. That means limit h tends to 0, f of 0 plus h means f of h minus f of 0 value is at x equal to 0, f of 0 is 0. So this value is 0 divided by h, and limit h tends to 0, f of h is h sin h cos of 1 by h divided by h. Here h cancel and I substitute the limit. I got sine 0. Sine 0 is 0 and cos of 1 by 0. Cos infinity, this value is anything, then sine 0 0. Multiplication of 0 value is 0. Finally I got the value 0. Limit exists. So f is differentiable. F is differentiable at x equal to 0. Similarly we have to check g is differentiable or not. What is the function of g of x? X cos 1 by x. So I write, we have to check g is differentiable at x equal to 0 only. So g dash of 0 equal to limit h tends to 0, g of 0 plus h minus g of 0 divided by h. Limit h tends to 0, g of 0 plus h is g of h minus g of 0 also 0, because x equal to 0 at g value is 0. So 0 divided by h. What is the value of g of h? G of h is, substitute x as h, we get cos of h into cos of 1 by h divided by h. Here h cancel. In this case cos of 1 by h has no limit as h tends to 0. Cos of 1 by h has no limit. Limit does not exist. That means as h tends to 0. So g is not differentiable at x equal to 0. F is differentiable at x equal to 0, but g is not differentiable at x equal to 0. So answer is option A. Answer is option A. Final answer is option A. Now the second problem, limit x tends to 0, sin x by x is dash. This question is from BT department. It has 1 mark. This is the standard result in limit. I think everyone knows the standard result in limit. That is, the value is limit x tends to 0, sin x by x equal to 1. And this standard result is used as a formula everywhere in calculus. So you should by heart the standard result in limits. Suppose you try to solve this problem in this way, that is, first I substitute the value, limit value, I got 0 by 0 form. In that place apply L'Hospital rule, that is limit x tends to 0, sin x differentiation is cos x, x differentiation 1. Next I substitute the limit, I got 1. It is wrong. It is wrong way to solve this problem. L'Hospital rule should not be used to solve this problem. This limit only be determined by geometrically. That way is take lot of time, so I didn't prove this result. I write the answer directly. The final answer, limit x tends to 0, sin x by x equal to 1. The final answer is 1. Third problem, the value of limit x tends to 0, tan x by x equal to what? This question is from chemical department. It has 1 mark. Here limit x tends to 0, tan x by x equal to, I can write tan x is sin x by cos x. Here one x is available. So next step is sin x, limit x tends to 0, sin x by x into 1 by cos x. Product of the limit of the product is equal to the product of the limit. This is the limit result. So limit x tends to 0, sin x by x into limit x tends to 0, 1 by cos x. Limit x tends to 0, sin x by x is 1. This is the standard result. Into limit x tends to 0, 1 by cos x also 1. So the final answer is 1. This is also one standard result in limit. Limit x tends to 0, tan x by x equal to 1. The final answer is 1. Now that fourth problem. Limit x tends to 0, tan x by x square minus x is equal to dash. This question is from civil department. It has 1 mark. I can write this problem tan x by x square minus x. So I take it outside x. I got x minus 1. In the next step, I write tan x by x into 1 by x minus 1. Here I use limit result, that is limit of the product is equal to the product of the limit tan x by x into limit x tends to 0, 1 by x minus 1. This value is no 1. It is in the third problem. Limit x tends to 0, 1 by x minus 1 is minus 1. So the final answer is minus 1. Final answer is minus 1. The fifth problem is the value of limit x tends to 1. Some rational function is given. This question is from computer science department. It has 2 mark. First I substitute the limit. I got x tends to 1. So I substitute the value of x as 1. 1 power 7 1 minus 2 into 1 power 5 1 plus 1 divided by 1 minus 3 plus 2. This is 2 minus 2 0 by 0 form. This is indeterminate form. Indeterminate form. So the next step, I apply L'Hospital rule, that is the derivative of numerator is 7x power 6 minus 10x power 4. This is 5x power 4, so 5 2s are 10 plus 1 differentiation is 0 divided by and 3x square. Derivative of denominator is 3x square minus 6x. In that place, I substitute the limit. I got x tends to 1. So 7 minus 10 divided by 3 minus 6. So finally, I got 7 minus 10 minus 3 minus 3 divided by, this is 1. Minus 3 divided by minus 3. So the final answer is 1. Option C is the correct answer. Answer is option C. The sixth problem is a function f of x is defined as f of x is equal to defined here where x belongs to R. Which one of the following statement is true? Here all the four options have f of x is differentiable, not differentiable at x equal to 1. So we have to check f of x is differentiable or not at x equal to 1 only. This question is from EE department. It has 2 marks. Here I have to check f of x is differentiable or not at x equal to 1. So I took f dash of 1. This is the definition of derivative. Limit h tends to 0, f of 1 plus h minus f of 1 divided by h. So limit h tends to 0, f of 1 plus h means e power 1 plus h. That means here h less than 1 and h greater than 1. This is piecewise function. So h greater than 1 condition and h less than 1 condition. First condition is h less than 1. In this case the function is e power x, that is e power 1 plus h minus f of 1 is e power 1 divided by h. This is h is less than 1. Next case, limit h tends to 0, x greater than 1, case h greater than 1, I substitute this function log x plus log of ax square plus bx, etc. So log of 1 plus h. F of 1 plus h means put x as 1 plus h. Put 1 plus h plus a into 1 plus h whole square plus bx. b into 1 plus h, because the function is f of 1 plus h, minus f of 1. Minus f of 1 means minus of log 1 minus a 1 square, that is a. Next, plus b. X is 1, so minus b, minus of f of 1. So divided by h. This value is h greater than 1. In this case, I apply h tends to 0. I got e power 1 minus e power 1, that is 0 by 0, indeterminate form. Next, in this case, here h tends to 0, I got log 1, log 1, log 1 cancel. Here I got a cancel. And here I got b cancel. So, h tends to 0. Numerator is 0 and denominator is 0. In these two cases, I got 0 by 0 form, indeterminate form. So, in that place, I apply L'Hospital rule. L'Hospital rule means the differentiation of numerator is e power 1 plus h into 1 divided by 1 only. This is constant, so this is also 0. This is also h differentiation is 1. So e power 1 plus h. Second condition, this is h less than 1. The second condition is these three values are constant. This is only differentiable. So limit h tends to 0. Log of 1 plus h is 1 by 1 plus h. A into 1 plus h whole square is 2a into 1 plus h, and b into 1 plus h is plus b. Divided by, these three are constant, so value is 0, and divided by 1 because h differentiation is 1. This case is h greater than or equal to 1. So limit h tends to 0, this value is e power 1 e, and limit h tends to 0, this value is 1 by 1 plus 2a 1 plus 0, 2a plus b. So finally I got this is 2a plus b plus 1. In this case h less than 1, this is h greater than or equal to 1. These two values are equal, then only f is differentiable. These two values are equal. 2a plus b plus 1 equal to e. Two side limits are equal, then only two side limits are exists. That means two sides limits are LHL and RHL equal, then only limit exists. Then only f is differentiable. So f is 2a plus b plus 1 equal to e, then only f of x is differentiable at x equal to 1. So it is not differentiable at x equal to 1 for any values of a and b. This is wrong statement. And f of x is differentiable at x equal to 1 for all values of a and b. No, the values of a and b satisfying this condition only, then only the function is differentiable. So this is also wrong. F of x is differentiable for all values. So this is also wrong. The final answer is f of x is differentiable at x equal to 1 for the unique values of a and b. This is the final answer. Answer is option B. Answer is option B. Seventh problem is, let g of x and f of x are given. Consider the composition of f and g, that is f composite g of x equal to f of g of x. We have to find the number of discontinuities in the f composite g of x present in the interval minus infinity comma 0. This question is from EE department. It has 2 marks. First, I check the f of x. The function f of x is continuous in what interval? Okay, limit x tends to 0. Here this is piecewise function, so limit x tends to 0 minus left hand limit at x equal to 0 in f of x is limit x tends to 0 minus means x less than 0 values, x tends to 0, x less than 0 is 1 minus x. This is 1. So left hand limit at x equal to 0 is 1. Limit x tends to 0 plus f of x equal to limit x tends to 0, x greater than 0 function f of x is x square. This is 0. but f of 0 equal to 1. 1 minus 0, 1. These three values are equal, then only f is continuous at the point x equal to 0. But here LHL and RHL, left hand limit, right hand limit, and f of 0 not equal. So f is discontinuous. Discontinuous at x equal to 0 only. But f is continuous and the interval minus infinity to 0 and 0 to infinity. But f is discontinuous at only x equal to 0. But f is continuous. Continuous at the interval minus infinity comma 0 and 0 comma infinity. Here I need minus infinity comma 0 only. So I write I minus infinity comma 0. Similarly, we have to check the function g. G is also a piecewise function. It is x less than or equal to and greater than or equal to 1. So I took limit x tends to 1 minus left hand limit at x equal to 1, g of x equal to, that means limit x tends to 1, x less than 1 value is minus x, so minus 1. But limit x tends to 1 plus g of x equal to limit x tends to 1, x greater than 1 value of g of x is x plus 1, this is 1 plus 1, 2. These two values are not equal. Again g of 1 is equal to 2 and minus 1. So these two values are not equal. In this case left hand limit not equal to right hand limit. So g is discontinuous at x equal to 1. But g is continuous on the interval minus infinity comma 0. G is continuous on the interval minus infinity comma 0. Here I use one theorem. That theorem says if g is continuous on a and f is continuous on g of a, then the composite function f composite g of x is continuous at a. Here g is continuous at minus infinity comma 0 and f is also continuous minus infinity comma 0. Therefore f composite g of x is also continuous and g minus infinity comma 0. Continuous on minus infinity comma 0. So the number of discontinuities in f composite g of x in the interval minus infinity comma 0 is 0 because the function f composite g of x is continuous on the interval minus infinity comma 0. So the number of discontinuity point in the interval minus infinity comma 0 is 0. So the final answer is 0. Answer is option A. Answer is option A. Eighth problem is the value of limit x tends to 0, x cube minus sin x by x is what? This question is from mechanical department. It has 1 mark. First I substitute the limit. I got 0 cube minus sin 0 by 0, that is 0 by 0 form, indeterminate form. So in that place I use L'Hospital rule, that is the derivative of numerator is 3x square minus sin x differentiation is cos x divided by x differentiation is 1. Then I substitute the limit. I got 3 into 0, 0 minus cos 0, 1 divided by 1. That is final answer is minus 1. So answer is option D. Answer is option D. Next, this ninth problem is the value of limit x tends to infinity. Some functions are given. This question is from MN department. It has 1 mark. First, I substitute the limit x tends to infinity. I got infinity power infinity. So infinity power infinity form. In this case, I took the function as y. Y equal to this function is y. Y equal to x square plus 2x minus 1 divided by 2x square minus 3x minus 2 whole power 2x plus 1 by 2x minus 1. Taking log on both sides, I got this is log. By using one logarithmic rule, the power getting into the front. Okay, 2x plus 1 by 2x minus 1 log of x square plus 2x minus 1 divided by 2x square minus 3x minus 2. Next, I took the limit in log function. Limit extends to infinity. Log y equal to, this is limit extends to infinity. This function 2x plus 1 by 2x minus 1 and log of x square plus 2x minus 1 divided by 2x square minus 3x minus 2. Limit of product of two function is equal to the product of the limit of the function. This is the one property of limit. So limit extends to infinity. This one is limit extends to infinity. Take it x outside. I got 2 plus 1 by x divided by x into 2 minus 1 by x. In this place, limit extends to infinity. Log of, here I took outside x square, 1 plus 2 by x minus 1 by x square divided by x square, 2 minus 3 by x minus 2 by x square. Here I use one result, that is limit extends to 0 or 1 by x power r equal to 0, sorry, infinity. Limit extends to infinity, 1 by x power r equal to 0 if r greater than 0. So in that case, this is 0, 0. Limit this function, all functions are 0. X cancel, x square cancel. So finally I got limit extends to infinity. This value is 2 by 2, that is 1. And this value is log of 1 by 2, log of 1 by 2. So final answer is not final answer. Limit extends to infinity, log y equal to log of 1 by 2. So limit extends to infinity, y means that function, the given function, equal to e power that value. Limit extends to infinity log y, that is log of 1 by 2. E and logarithm, exponential and logarithmic function cancel. Final answer is 1 by 2. So the final answer is 1 by 2. Option A. Answer is option A. Now let's move on to the 10th problem. If f of x equal to e power modulus x, then at x equal to 0, the function f of x is continuous and differentiable, etc. We have to check the function f of x is differentiable and continuous at the point x equal to 0. This question is from MT department. It has 1 mark. First, I check f is continuous or not. So, I find the left hand limit at x equal to 0 and right hand limit at x equal to 0. These two values are equal. This is also equal to f of 0. Then it is continuous. That means limit extends to 0. F of x is e power modulus x. That means modulus x function. How to define modulus x function? If x greater than 0 minus x less than 0. This is the definition of modulus x. In this case 0 minus, so e power modulus minus h. This is also plus h. Extends to 0 means e power 0 1. Limit extends to 0 plus, this is right hand limit, f of x equal to limit extends to 0 e power modulus h, not modulus h, this is x, modulus x, this is x. So in that case e power 0, this is also 1. So f of 0 equal to e power 0 1. These three values are equal. Left hand limit equal to right hand limit equal to f of 0. So f is continuous at x equal to 0. F is continuous at x equal to 0. Next I check differentiability. By the definition of differentiation, derivative is limit h tends to 0, f of 0 plus h. Here at x equal to 0 only, so I took f dash of 0. F of 0 plus h minus f of 0 divided by h. Here f of 0 plus h is f of h. What is the value of f of h? F of h is e power modulus h minus f of 0 is 1 divided by h. I substitute the limit, I got e power 0 also 1, 1 minus 1 0, 0 by h tends to 0, 0 by 0. This is indeterminate form. So in this place I use L'Hospital rule. L'Hospital rule means differentiation of numerator is e power modulus h Modulus h differentiation is h by modulus h by modulus h, and this differentiation is 0 and denominator differentiation is 1 divided by 1. So I substitute limit, I got two cases, h less than 0 and h greater than 0, because here modulus h function is available. In h greater than 0, I got the positive values, positive e powers. Okay, h greater than 0, I got the positive values, but h less than 0, I got the negative values. So two-sided limits does not exist. That means these two limits are not equal. Left hand limit not equal to right hand limit. So f is not differentiable. F is not differentiable at x equal to 0. F is continuous but not differentiable. So the final answer is A. Answer is option A. Now 11th problem. 11th problem is, sorry, this is F is continuous but not differentiable. So answer is option B. F is continuous but F is not differentiable. So answer is option B. Next. 11th problem, the value of limit extends to 0, 2 plus x whole power 4 minus 16 by x is dash. This question is from PE department. It has 2 mark. First I substitute the limit. I got 2 power 4, 16, 16 minus 16, 0, 0 by 0 form. This is indeterminate form. So in that place I use L'Hospital rule. I apply. So the derivative of numerator is 4 into 2 plus x whole cube into 1 minus 0 divided by 1. Next, I substitute the limit. I got 4 into 2 cube. So, 2 to 8 into 4, 20, 32. The final answer is 32. Now, 12th problem. For a complex number z, limit z tends to I. One function is given. We have to find the limit of that function. This question is from EE department. It has 1 mark. First, I substitute the limit. I substitute the value of z as I square is minus 1 plus 1 0. Similarly, I got the denominator also 0. So 0 by 0 form, indeterminate form. In that place I use what? L'Hospital rule. Z tends to I. What is L'Hospital rule? Differentiation of derivative of numerator is 2z divided by derivative of denominator is 3z square plus 2 minus I into 2z. I into 2z. This is the derivative of denominator. I substitute the limit. I got 2I by 3I square is minus 3 plus 2. Here I square is minus 1 plus minus 1 plus 1 plus 2. So finally I got 2I by 1. The final answer is 2I. So the option D is the correct answer. Answer is option D. These 12 problems are the GATE 2017 engineering mathematics questions related to the concept, limit, continuity and differentiability. If you have any doubt in this topic, then you can ask in the comment section. Let me try to clarify your doubts. Thank you. See you in the next video. If you like this video, please like, share and subscribe my channel to encourage me. Thank you.